The last double displacement reaction we're going to study might seem misplaced amongst all of this acid-base talk, but in reality, it's very closely related. The acid-base process that we have seen involved the transfer of a proton to a hydroxide ion to form water. The gas formation reaction we will see in this video also involves the transfer of a proton from an acid, either weak or strong, to the bicarbonate or carbonate anions. Again, acid-base reactions and these gas formation reactions are a little bit of a same album, different song situation. So let's say we have an acid in solution and we add to that a metal bicarbonate, or we could add a metal carbonate. Either of those two anions will result in the same types of products at the end of the day. Now we once again have aqueous solutions of our reactants. So we have mixture of ions on that reactant side. And those ions can do the double displacement thing and swap partners. This results in the formation of a salt and carbonic acid, or H2CO3, shown here. Now it's still true that the salt is aqueous and that it's going to dissociate into ions in solution. And it really appears that the carbonic acid is aqueous and it should dissociate, but in reality, it does not. And that's why this reaction gets its own reaction type. Have we mentioned before that chemistry is just the most fun? Now, my goofy sarcasm aside, I bet you're shaking your fist at the sky screaming, but why not? Well, it turns out that this here carbonic acid molecule is unstable, and unstable things tend to decompose instead of dissociate. And indeed, carbonic acid is known to decompose to one gaseous CO2 molecule and one molecule of water. These decomposition products are what should be included on the product side instead of H2CO3 in a double displacement reaction such as this. Now this one is really easy to get wrong because when you do the double displacement swap, you'll end up with two aqueous compounds, and in section 2.2, that meant no reaction. But there, we wrote no reaction because everything was unchanged in form from one side of the reaction arrow to the other. Here, that is in no way the case, as we formed not one, but two new states of matter, and therefore have to say a reaction has occurred. So, make a note that you will need to pay special attention to carbonic acid if it is a product that you form. You'll not have an indicator other than your recollection of that come quiz time. Again, I've included some specific examples of gas formation reactions. In each of these three cases, and in all of our carbonic breakdown reactions, the water and the carbon dioxide were carbonic acid first. Keep in mind that this, our last double displacement reaction, is the one and only reaction that you will list as gas forming come quiz time. This is actually an important note, as you will see oxidation reduction reactions that can form gases as products in the next section. But those are best labeled oxidation reduction reactions because they're going to come with a change in oxidation state. More later, don't panic. For quiz purposes, the decomposition of carbonic acid is the only gas forming reaction that you're going to label. Know that there is a sulfur version of the same template that might show up on your homework though. The only difference is a central sulfur where I placed the central carbon in that earlier animation. So this video still helps answer those questions.